Move it around a little bit. I have multiple options here. Okay, so today we're talking about quadratics. Quadratic is really just any term when you have a polynomial with a bunch of terms. It's the term that has to the second power right there. That's a quadratic we're mainly dealing with in high school here. So when you see to the second power, you know you're dealing with a quadratic. You know you can put it in the standard form here in order to figure out a bunch of other stuff. So I'm going to get to that side of the board in a second. But before, I'm going to hold this up. Anybody know what the heck this is? Yeah, it's a Da Vinci catapult. Built this a couple years ago. I had this envisioned that it would shoot the ball like all the way across the room. I was real excited. How far do you think it's going to go? Not that far. But the reason why I'm showing you this is the same thing for this little, I have this little like foam little gun thing here. If I throw or shoot any object on Earth with gravity 9.8 meters per second towards the ground, gravity does minutely change around the world slightly, but we're not worried about that part. Any object you throw or drop follows a parabola. I guess if you drop it, it's going straight down, but if you throw it out from a cliff, it's going to go down like a parabola. Okay, so I'm going to shoot this. Tell me this, what's that? What shape is it? Did you see a triangle? Did you see a circle? You saw a parabola. Every single object will fly like a parabola. Nice catch, by the way. So let's see about this one. 3, 2, 1. Ooh, that one actually went pretty far. Okay. I put some extra rubber band on it. So I just want to point out that there's some things you can know about a parabola that are helpful. So anytime anything is being launched, like if you were launching someone out of a cannon, right? Launching them out of a cannon, you better have all this math right, because they're right here, they're ready to go. And if you're launching them out of a cannon, right? You're going to shoot them up. From here, is it just going to get up to the maximum and just fall down? What's going to happen? I mean, we know this. You've seen it. You've thrown a football or a basketball or a baseball or something. It goes all the way down. And this axis of symmetry kind of cuts things in half. We're going to talk about that too. The helpful thing is you'd be able to figure all this out. And honestly, most of you are going to have kids someday. Your kid makes this like little ramp, wants to jump his bike off the ramp, makes the other ramp like 15 feet away. You're going to say, your axis of symmetry is equaling a broken arm right now. Okay, so, these little things are going to happen. Little basic things you can know about the shape, flight of balls, flight of kids. You can keep your kids from landing wrong. Okay, so that's just way off in the future, just pointing that out. It is going to be helpful just as the intuitive part. But we're going to go a little past intuitive. We're going to learn it to a pretty far extent. First, I want to bring your attention up here, though, because we look here and we've seen a lot of this already. If you can see that at home, you have eagle vision. All right, let me just make it a little bit easier for them at home. All right, yeah, that's pretty good. All right, let's look at this. We have Desmos here. Desmos is a free app you can get online. This is the online version, but the free app at home, you can use it without Wi-Fi or data, so it actually is helpful. I'm going to make you get that in the next week or two here. But get it on your phone if you haven't yet. Right now we have it set so A is 1. Here's my A value, ax squared. B is 0, C is 0. So what happens to these two terms right here when B and C are equal to 0? What's going to happen right there? 0 times x, 0, plus 0, 0. So these two terms here become 0. So essentially right now I have A is equal to 1. So I have y is equal to x squared. This is called a parent function. A parent function is one that you could move, you could stretch. But the basic quadratic, the basic parabola goes down the vertex here at 0, 0, and it continues up. And tell me right now, what do you think the axis of symmetry is? Where is it? Tell me when I get there. There? There? The axis of symmetry. Symmetry just means it's the same on both sides, and that's the axis. If you were to fold it in half, it would match exactly. Okay? So keep all that in mind. What do you think is going to happen if I change my C value? Maybe you've looked in your notes already. You have an idea. But what's going to happen if I can push play right here. If I push play, it makes the C values go from -10 to 10, and it'll just keep going back and forth. So tell your neighbor, 1 second, just tell them real quick, what's going to happen? What do you think when we change C? If you don't know, it could be, I don't know. Tell your neighbor, real quick. You figured from there, right? You got it? When do you have, what happens?
I don't understand.
Okay, no problem. So you see up here we have our equation. This is standard form. The C value, and you haven't seen this before, so watch. The C value when it goes up towards 10, what happens? Right? It goes down to 10. It goes down. Now why is that so? Because right now we have the parent function, right, when it's at 0. So those first two terms are gone. And essentially, if you have this and you added 1 to it, it's going to move everything up 1. That is the basics. We're going to have to transform them more later. I just want to show you. So I can push play. Like what happens? It goes in between. Fancy, right? Okay. All right. There's more. Let's get it back towards 0. Last time I missed it by 600ths. All right, what do you think is going to happen when I change out A? This one's really important, actually. The very, very right side of the board might have a hint. Okay, so you're saying it'll almost like, and then bow down. Okay, let's see. I think that's a good guess. So, oh, there it is. Goes down. What is the point, or what value do we have it where it is a straight line? Let's see if that works. Would that work? Let's see. We'll pause it. Let me see if I can get it. That's impossible. I cheated. All right. You see how it's a red line right here? It's barely visible, but it's a red line because what do we have? C is 0. B is 0. A is 0. Is there any value on the right side, or is it equal to 0 now? If A is 0, that term's gone. B is 0, that term's gone. C is 0. So Y is equal to 0 as a horizontal line right there at 0. Okay, yeah?
So a straight line is considered a parabola.
I am really glad. I couldn't have asked for a better segue than that. Okay. So in Einstein's theory of relativity study, thesis, he starts off talking about parabolas. Because if you're sitting underneath the Gateway Arch in St. Louis, you're sitting right, you're laying down right underneath it. You're looking straight up. What do you see? You don't see a parabola. What do you see? Straight line. So this is the start of his theory of relativity, saying that the perspective you take to an action or situation can change the situation. So, if I shoot it this way, right, Santana sees a parabola. If I shoot it this way, watch out. If I shoot it this way, what'd you see then? A straight line, right? So that argument went to like the postulate that, an object, he has this thing where it's a plane going at closest speed of light. Somebody throws something in the plane, but your perspective down on Earth would make that object look like it's going in slow motion. There's all these beautiful theories that have been proven correctly. And he started that whole argument by saying, yeah, parabola looks like this, unless your perspective is right underneath it, and then it looks like a straight line. And if anyone gets to master's level studies in math, you'll get further a deeper idea about that. Okay, so this is just like starting out. I just wanted to give you a perspective. Last time I taught this, I spent a whole day kind of like breaking it down, but now I want to get into the nitty gritty. So I'm going to take this off, put this over here. Let's see, can it just sit here? That'd be take it. Can it sit there? Yeah, no. Let's see, fine. Okay, so we have this process now. We're going to keep referring to this as we do the problems on the left side. So to start here, this is all we got to start with right now, the blue box. Okay. By the end of Unit 3, we're going to know how to use factored form, and vertex form. But right now we're using standard form. These are just three different ways to get to your parabola. Okay. So when I'm looking at this, the first time I taught this, I realized that the book does not do a good job getting us down to factor form. It's really complicated to factor some things. We're going to use algebra tiles. It's really going to help, especially if you need more than one way to think about a concept. That's really going to help. We're just starting here. I just wanted to give you a big picture of the things we're going to have to learn in the next couple months. Okay. Now, let's bring ourselves over to this side to look real quick. And everything we need is in this equation. It's going to be a little bit hard, so I'm going to, for me to do the problem here and video this, so we're going to first just look through our steps. First step, tell me when it gets hard. You're going to be given a function like this, a quadratic. You need to find what your a, b, and c values are. Let's see where those values are located. A is in front of x squared. B is in front of x. C is by itself. So right here, somebody just tell me what our c value is. -2. C. What's my b value? 4. It's just the coefficient. And that's an easy assumption to make. But if you look at our b value, it's b times x. B times x. So we're looking at the coefficients. Essentially, -2 is -2x to the 0. You can think of it that way. It's still a coefficient. But in that case, we just call it a constant. How about a? Perfect. You saw that? It's -1. Okay. Very hard to find a, b, and c? Is that quick? It's quick, right? If you know where to look, it's quick. And it is just coefficient here, constant. Get them in there pretty quick. Okay. Now, let's see. First step to be able to graph this is to find this axis of symmetry. Now, I did that with the laser, remember, with our parent function x squared. It was right in the middle, right? Now, once you find the axis of symmetry, then you're in pretty good shape to then find the vertex, because let's look where the vertex is. The vertex is on that line of symmetry. And think about it. If I have a parabola right here, let's say this is 1, 2, -1, 2. Tell your partner, your neighbor, approximately where is this line of symmetry going to be for those sketches? Just tell your partner. Can't see. All right, anybody want to use the laser in the front row or second row? Nobody. Lasers.
Am I too far?
If nobody looks, Santana, don't look back. All right, so put it right on the line of symmetry. It's hard to hold it straight, huh? Is that it right there? Hey, wait, I need to dash it. Hold it still, man. Jeez. No, that's not right. No, you're right. What would you call it? X is equal to? There it is. Up. And they go parallel to that. The desk isn't totally straight. You guys agree? That line breaks it in half. It's like if you folded the piece of paper, you get right in the middle. Now, there's a very important, thank you. You could turn it off just in case I cross it. It's like, it's there. And the other side. You'll get it. Okay. I could fold this in half, right? Okay. The one most important point in an entire parabola, the most important point is this point right here. This is called the vertex. What's something you notice about the vertex? Give me one thing. What's one thing you notice? Just call it out. What's one thing you notice about the vertex? Where it is, what it's aligned with, anything. It's the lowest. Good. And if it's on the very bottom, do you think we call it the minimum or the maximum? Minimum. Probably won't have to say that again, right? It's at the bottom, it's the minimum. How about if it was one shaped like this? Maximum at the top, minimum at the bottom, right? Okay. So that's really important because once we know the axis of symmetry, right, we could find the vertex from that. I know the vertex is on the line of symmetry. So once I find the line of symmetry, we're going to work all these out. Then I know my x value for my vertex. I like to label it this way too. A big V, colon, and then the ordered pair. That's how I show it, the vertex. So we have that. We got to plug in to find our y value. And from there, we know if it faces up or down. If A is positive, it faces up. Smiley face. If A is negative, it faces down. Sad face. I feel like those are pretty intuitive to help us figure it out. The y-intercept is just C, because if we look here, right, if that was 0 for x, we'd only have C left over. Y is equal to C. So we know that our y-intercept is equal to C. Let's see if we can put all this together now. After 2 examples, we will have it. All right, here we go. We already found it A, B, and C. That's step 1. Step 1, A, B, and C, done. Step 2 is find the axis of symmetry. So the axis of symmetry, axis, S-Y-M, you can just write it that way, axis sem. All right, we'll get that if we know what that is. Okay. The axis of symmetry, if we're going to graph it over here, is going to be a vertical line. X is equal to something. And we find that by plugging this in. X is equal to negative b over 2a. Every single time we're going to plug in for a and b right there. So I want you to just go ahead and put our a and b in here. And let's see if we could find where our axis of symmetry is. Axis of symmetry. So go ahead and work that out. Be careful with your signs. So we have x is equal to 2. The vertex is going to be a point, an x and a y value. Do I know any information to put in there? Tell your neighbor. What am I going to put in for the vertex? I just figured out the axis of symmetry is that x is equal to 2, so I might go here at 1, 2. I'm going to even label it x is equal to 2, so we keep remembering that a vertical line is an x is equal to something, some constant. Tell your neighbor, what do we know about the vertex? Is there anything we know that's going to help us with our next step? Yeah. Okay. Let's see. Miley, what'd you guys come up with? Okay, that's quick. You're ready for it. So once you find the axis of symmetry, you've already done half the work for the vertex. You know the vertex is what? The vertex is on the line of symmetry every time. So we know that it's on this line. We just don't know where it is. So what do you think we have to do if we know an x value? What do we do to find the y value? Plug it in. Y is equal to negative 1 parentheses 2 squared. It's not the negative 2 squared. 4 times 2 minus 2. You see right here, put parentheses. Otherwise, you might misunderstand it as negative 2 squared, which is not correct. We do exponents first. I'll get you to the next line here if you need it. 4, I'm just going to add these, or multiply. Negative 1 times 4 plus 8 minus 2. That might be enough to get us there. Yeah. Y is equal to? 2. That goes there. The vertex, x value we got from finding the axis of symmetry. We know those are aligned. We plug in to find the y. Go ahead and plot that point right here. And I might even put the vertex in there as 2, 2. All right? Now, here's the thing. These happy face, sad face help us know if it opens up or opens down. Look at that problem and tell me, happy face or sad face? A is negative, so it's sad. You may say it's kind of a silly way to remember it, but you'll remember that after we do it a few times for the rest of your life. Because A is negative, it faces down, sad face. When A is positive, it opens up, happy face. Easy. Right. I mean, I could write that out in an unhelpful way, but I like to use a mnemonic device like so. Okay. So let's see. We know this is going to open down. We have one more step. Step 4 is we know that the Y-intercept. And here's the deal. The Y-intercept is equal to the C value because the Y-intercept is where X is. Here's X is 2, X is 1. When is it going to intercept the Y-axis? X is 0. At X is 0, you're on your Y-axis somewhere. So you plug in 0 here, this term is 0. Plug in 0 there, that term is 0. What's left over is just your C value. So the Y-intercept is equal to -2. So watch, I go down here. 1, 2, -2. Put another point. We're going to go down that way. And then is the right side of the graph going to look the same or different? Same, because the axis of symmetry is what we're dividing this in half. I went from the vertex down through the Y-intercept. Now I said do the same over here. And I just kind of like look, even with the Y-intercept, it's going to be that same distance away from the axis of symmetry. Axis of symmetry breaks everything that way. So let's go down. There we go. That's done. The next step, we have to, when we go to factored form, the next logical step is to find where it crosses the x-axis, which are going to be called our roots. If we had that much information, we could solve this and have it really accurate, but we aren't there yet. So these are rough. These are rough. Okay. After the first example, how do we feel about this? Thumbs up, sideways, down. It is kind of cumbersome. There's new language to it, so don't worry if it's here. Good. Perfect. I want to do one more and then set you loose. There also will be at the end of Unit 3 an opportunity to shoot a water balloon in a parabolic shape, and I'll be standing out in the field, and you can try to hit me. It's gonna be great. I really like water balloons. The last day of school last year, I had a huge water balloon fight with all my students, all my kids. So you'll see. Once we have the first end of the year party, you'll see the extent that I go for those kind of things. It's 12th level, man. It's crazy. It makes a difference if you enjoy the community you're a part of, right? So it actually does. Let's do this one. What's my A?
2.
2. What's my B?
-8.
C? 6. Okay. Did we do step 1? Yes. Step 2, axis of symmetry. Axis sim. X is equal to negative. Put something in there. Put something in there. What goes in those two spots? Which spot does the 2 go in? The bottom. We know that's A. We know that's B. Good. This right here, actually, for now, this is the only formula you need to memorize. X is equal to negative B over 2A. X is equal to negative B over 2A. So we work this out. This is going to end up being positive 8. That's 4. So we got X is equal to 2. Again? No way. So let's go over to 1, 2. And we're going to make our dashed line. What do we know lands on that line? What is going to be on that line, aligned on that line? What is it going to be? What do we find on the axis of symmetry? A bunch of dashes. There's something that we're going to find on this axis of symmetry that's the most important point. What are we going to find that lands on the axis of symmetry? vertex, heard vertex, vertex, perfect. So that was kind of alluding to step number 3 when we get to the vertex. We know we're going to end up with an x and a y. Do I know one of those already? I do. Because the axis of symmetry and the vertex have this x value in common. That shows and reminds me they're aligned, so I already have half the information. So I want you now to find y. How we're going to find y, go ahead and figure that out. You can ask your neighbor if you need it. I know my number I want to plug in. I want to see what the other side of this point is, the other dimension of the point. 2 and what? Just ask your neighbor if you're not sure. Or tell your neighbor if they don't look sure. Look at their face. Does it look sure or not? Judge by their face if they need. Slouching. Minor publication.
Oh, wait, I didn't.
Oh, I see. All right. What should we plug in? Plug in 2 into the original, right? You're always plugging it into the original. We're going to get y is equal to 2. 2 squared minus 8 times 2 plus 6. This is 2 squared, 4, times 2, 8. Minus 16, negative 8 times 2, plus 6. Go ahead and work those out together and see what you get then. Jack, what'd you get?
-2.
Perfect. So we have y is equal to negative 2. That is the other part of our puzzle. Now we know where the vertex is. We found the axis of symmetry. We used the axis of symmetry to plug in and find our y value for the vertex. Let's go ahead and plot. So I'm at the 1, 2, negative 2, and 2. So I know that we're going to end up with a vertex right there. Label that vertex for me. This is going pretty well. Tell your neighbor if it's happy face or sad face. Good. You got it. All right, show me on your face. Happy or sad face? All right, there's the slightly tired grin. I'm going to take that as happy. I like that you forced it. Good. So we know that A is positive. So it is a happy face. Which means, do we have a maximum or a minimum?
Maximum.
Everyone said it. That's peer pressure. Happy face. What does the shape of that parabola look like? Minimum, right? Minimum. One person said maximum in there. Maximum. Yeah. Well, if I was on a roller coaster and here was the path of the roller coaster, where would the maximum be? At the vertex at the top. If I'm on this part of the roller coaster, where it's going like this, where's the minimum? Bottom. That's it. It's a definition. That's the main thing. It's just a definition of labeling that point. So I know it opens up. What's the last thing that I could find? Step 4.
The Y-intercept.
Good. Y-intercept is equal to C. So it's equal to 6. So I'm going to go here at 6. 1, 2, 3, 4, 5, 6. Okay. Go ahead and graph that. Graph the the left side of that first, and then use the symmetry idea to kind of mirror it to the other side. Okay. This one's narrow, steeper. So I like to think of it this way. Here's the line of symmetry. To my y-intercept is about that far, so if I go over this direction, it's the same distance on both sides because it's symmetric. It's the same distance from that axis of symmetry. Got it. Done. Okay, I know on the complication level of what we're trying to accomplish, this is pretty complicated. On the step-by-step, let's look and see. Finding A, B, and C? Tricky? No. Easy, right? Axis of Symmetry, plugging in a B and a 2 and working that out. This right here, not so bad. Find the vertex by plugging in. This is probably the one where people maybe are like this. Okay, sideways. Happy face, sad face. I hope that is here. Y-intercept. I mean, you just got to remember that definition. So putting it all together, I mean, that's the complicated part. But each step, I'm pretty confident in you guys. I'm very confident. Each step you can do it, definitely with a partner. So we're going to work in partners for the last bit of time. Give me the thumbs up, sideways, down for the first day of quads. Pretty good? Okay. It's here. You got to do a couple more problems. The problems are on in Modo. You don't have your Unit 2 workbook yet. We'll get that next couple days. But I wanted to do this anyway because we're going to do like the second part of this tomorrow. Or maybe the next day. We might do algebra tiles tomorrow. Which are really going to help. Wait till you see how this works. All right, question? Question in the back? Was there a question? I thought your hand was up. All right, let's just tell these folks to subscribe. I'm on 225. Where did it go? 25 more. So we got a 1, 2, 3, make 25 fake accounts to win a Kit Kat. Just kidding. 250 is when I'll give it free Kit Kat. How about free Kit Kat in 25? How about that? It'll be random. People won't understand it. You guys don't like that at all. It's all over at Modo. I put the link there every time. Yeah.
Or you could just look up your name.
Just show it.
On YouTube.
Ah.
That's what I did.
Well, if you're watching the video, you know that it is subscribe. The video isn't over. That's that obviously. There's my face. All right, win a Kit Kat, 25 more. Don't unsubscribe in order to subscribe later. I don't want to get to 148 and then suddenly I have 248 and then I have like 199 because all you guys are Kit Kat. All right, that's it.